think we started to talk a little bit about number 44 in class yesterday, and that was one where I think I said, hey, look at this, where you've got right off the bat, excuse me, anytime that you see alternating signs, what I mean by that is, a plus and a minus for either variable, the x or the y, you know that you're going to want to add those two equations together. So now it's just up to you to decide which variable do you want to eliminate first. Do you want to eliminate the x's or do you want to eliminate the y's? If you eliminate the y's, you're multiplying the top equation by 10, the bottom equation by 7. If you eliminate the x's, you're going to multiply the top one by 11 and the bottom one by 3. Either way, you will get the same answer if you map it correctly. The big thing here is that when you write this down, to use good handwriting. A lot of you guys have suspect handwriting and you write rather quickly and you lose a little bit of what you can't see it as well. So like I also said, hey, take a second, space it out a little bit more when you're writing it. It makes it a little bit clearer to work with. So let's just say I'm going to get rid of the x values first. So I'll multiply top by 11, bottom by 3. Okay? Then I rewrite 11x minus 77y is 220. Make sure you go to all three parts. Oh, that right there. I was looking at the... Make sure you still go to all three parts and you do the math correctly. And then I go again, negative 33x plus the 30y is 15. Yesterday in class, I suggested, hey, why don't you split it up and make sure you're writing down that you're doing 3 individual math problems from here. When I do those 3 individual math problems, it forces me to remember that I'm adding everything. Because what happens a lot of times is the first one, obviously, they go to 0. The second one, they go to negative 47y. And then all of a sudden, you're like, oh, I subtracted those 2, and you forget. And sometimes somebody might write 205. So you got to make sure you follow through with what you're writing. We get 235, I believe. Okay. And then you divide that out, and I believe you get negative 5 for y. Does that sound right? Okay. Yep. Thanks, appreciate it. From there, does it matter which of the 2 equations I substitute the y back into? Exactly, just do it right. Personally, I would throw it into wherever I have a positive value of y, just because the double negatives sometimes make me screw up. Okay? And that's just me. You might be different. It doesn't matter. So we have negative 11x plus 10 times the negative 5 is 5. Oops. So for both x and y here, your ordered pair, or sorry, you get negative 5s for both. Okay? That's what we're doing. Going back to the other ones. On 45, there's a couple of things you can do, and this might help out a little bit when you get in towards 49 as well. You can make a couple of decisions as far as the fraction stuff is concerned. Me, I see it and I go, I don't really want to try and eliminate and work with fractions. So in my head, I want to try and just get rid of them. Okay? If we do the same basic idea here, if I multiply the top equation by 3, and I multiply the bottom equation by 1/2. See what's happening? If I multiply the top equation by 3, I get rid of the fraction, right? And if I multiply the bottom equation by 1/2, the first x coordinate, or sorry, the first x term becomes a -1, doesn't it? I'm using linear combination, getting out ahead of it. So if I do this, I'll show it in slower steps. If I multiply that top one by 3, I'm going to wind up with x plus 3y is 27. And then if I multiply this bottom one by 1/2, I get negative x plus y is -3. Everybody see that? It's the same basic idea as doing like multiplying the top by 3, multiplying the bottom one by 11. It's just that I did a fraction instead. Right? It still works. All right. Now, same coefficient, opposite signs. What do we do to the two equations? Add them. Very good. So I split them apart and I add them up. We get nothing. 4y is 24. So I get 6, 4, y. Okay. So far, so good? Okay. So now if I go back to the original equation, 1/3 of something plus 6 is 9. So that means that if I subtract the 6, I get 1/3 of some number is 3. 1/3 of what number is 3? 9. Very good. Remember, to undo the fraction, you would multiply by its reciprocal. You get 9. Then our ordered pairs would be 9 and 6. Okay. There are probably other ways to do that one. I thought that was a kind of a clean way of going about it. Doing the fractional stuff. Okay. What's that? How? By 2? But then you'll have 2/3 x plus 2y. Then you'll have fractions to still deal with when you combine them. Yeah. I mean, it's up to you. If you want to do it that way, that's fine. I'm all for using fractions and going about it, but I think that a lot of times we do this stuff, we steer away from the fractions to start with. It's easier algebraically, okay? That's just, again, that's just my perception to make things a little bit simpler. But if you did it that way, you should still get the same answer if you follow through the operations right. Okay, and that's good. All right. Are you guys okay? I know you have some questions.
Can we do one?
Absolutely not. He's like all hardcore. He said, but I have a question.
Were you crying?
I'm going to do those, Greg. Don't worry. I'm just messing with you. In case you haven't figured out, just
I know.
Well, I'm sorry. You need an Air 5? Oh, that sucked. Come on. Better. You can do it. Come on. I know, it's early. Before I get to the 2 word problems, are we okay? Is there any of the other straightforward ones we want to double check? Sure. So, in this case here, bless you. In this one here, I'm sure most of you guys noticed that you have opposite signs for the x and y's. And if I multiply the top one by 3, we get 36x plus 9y is 48. Correct? So that means then, if I split this up and I add them up, does 0 equal 7 or 80? No. So is this either a no solution, or is this going to be infinite solutions? Why is it no solution and not infinite? They have the same slope, but they don't have this, but they're not the same line. Okay. If you go through it, you'll recognize the opposite of A over B. You get what is that? 3 over 12, or I'm sorry, negative 12 over 3. So we have negative 4. Here you've got 36 over negative 9, which is also negative 4. They have identical slopes, but what they don't have is they don't have the same intercepts. So these would be, this is a no solution because they are parallel lines. Okay? If it wound up being a true statement, like 0 equals 0, then it would be infinite solutions because they are in fact the same line. That's the difference. Okay? Does that make sense?
Yes.
Yes, sir. But it could be like 6 equals 6, or if it's a true statement, then you're good to go. All right. What was someone else said something else? Was it 46? Someone was saying? Did I hear someone say 46?
No.
Well, you're good then. All right. Breaking even. So when you think about the idea of breaking even, so this is the best.
I like the pepper jack.
I don't like cheese. I don't like cheese, so now, easiest idea to talk about how you break even is I buy peanut butter crackers at Aldi every week. I buy a pack or 2 of these things because these are a great little snack because you don't want to see me when I'm hangry. It's not a pleasant sight. My wife has to carry food for not only our children, but for her grown-up child as well. Okay? Because I will get snippy and I need to eat food just because I have the metabolism of a 12-year-old and I need to eat nonstop. That'll catch up to me eventually. But anyway, the idea here is these things are $1. All right? This is maybe 95 cents. It's maybe $1.20. I don't know. They're cheap. So if these are $1 and I want to turn around and sell them, there were 6 of them in there, and if I sold each packet for $0.25, how much profit would I make?
You would make some profit.
How much?
It's 50 cents.
I would make 50 cents profit. Exactly. The idea here is that I purchased something for $1 that I'm going to in turn and flip and make money off of it. What happens is that there's an upfront cost that I had to incur to be able to get this to market, if you will. Now, I'm not including the gas money or the quarter that I lost when I got my shopping cart or at Aldi or anything like that. But the idea, it's a joke.
You get it back.
I know, it's a joke. Anyway, so the idea here is if I buy 10 of these, it costs me $10. Okay? And then I need to figure out how many that I have to sell at 25 cents a piece before I would turn a profit. That's kind of what this first problem is like. You're purchasing something that you want to mark up in order to have what, you guys ever heard the term called a margin? Okay, sales margin is something where it's just what we call profit. Like I said, if I'm buying my package of crackers for $1, what? If I'm buying the package of crackers for $1 and $1, and there are 6 of them, it basically means each one of those packages costs about 17 cents. You okay with that? Now, if I sell each one of those for $0.25, that means that the initial, well, we'll just call it 17 cents for the initial. My sale is this. What's the difference between 17 cents and 25 cents? 8 cents. Do you guys remember finding percentages? Change over original. So if I'm making 8 cents per, and I divide that by my original, It means I'm making a 47% profit on each package of crackers that I sell. Now, 47%, that's what you call your margin, okay? That's pretty darn good, okay? Even though it seems like something so small, but yet if you sell enough of them over time, you make a pretty decent chunk of money on them, all right? It goes along with the idea of, you guys ever heard of what's called a commodity? What's a commodity?
Oh, shoot. I don't know.
Well, if you're not staring at your phone, you might be able to figure it out. Sure.
Commodity is when you buy a bundle of a supply, and then you just choose a first item.
Yeah, but can you give me an example of something I would go and buy a boatload of?
So let's say you have like a small game, like microwave game.
That's good.
Now let's say you need to buy like 20 shows.
Okay.
It costs like $50. If you were to buy like 20, it would cost like maybe like $40.
Okay, yeah, they give cut you a break on something. When I think of commodities, I think of building materials. 2x4s. 2x4s are a sales commodity. Drywall, sales commodity. Come by nowadays. But the idea that if you go to Menards or Lowe's and you buy a 2x4, a 2x4 costs you $3. I think, I don't know. They don't sell that at any profit at all. Commodities, are rarely sold at a margin great enough to make any money. A lot of times the commodities are sold below profit margin. For example, it might cost Lowe's $2.99 per 2x4, and they're only selling them for $3. So they're making a penny, if that. Sometimes they barely break even on some of those things. Where stores like that actually make their money are the things that you need to do things with. Nails, screws, hammers, things like that. That's where they make all of their money. Drywall is cheap. Drywall costs $4 or $5 per sheet, and it costs $4 or $5 per sheet to make. They make zero money on the drywall, but in order to hang drywall, you have to have screws, you have to have joint compound, you have to have tape, all the mud and all that kind of stuff, the trowels to do all that. You have to have that stuff in order to use it. That's where they make all of their money. Those things are sold at a margin, probably like this, about a 30 to 40% margin. Okay? That's where the idea of sales stuff comes in. What do you have to do to turn a profit? And it kind of goes into this problem that you guys were asking about here with the breaking even. If I want to talk about breaking even here, what's the snap in here? If I want to talk about the idea of breaking even, I have to figure out how much am I paying up front. So as you read this one, it says I'm making a business of selling hand-painted greeting cards. Let me just say, I am the greatest artist of all time. So my hand-painted business card or greeting cards would just be the best things ever. You guys would all be so jealous. Shut up. Yeah, ready? Yes, sir. No. Wait till Christmas, right? No, anyway, you guys would pay me not to draw. Yeah. So to get started, I spent $36 on paint and paintbrushes that I need to create my business. Along with that, I'm going to buy a box of plain cards for $3.50 per box. Then I'm going to sell them for $5 a piece. What I need to know is, where will these two values meet? Where will I break even? So again, think of it this way. How much money do I have to pay up front for paint and paintbrushes? 36 bucks. Now, I am buying $36 worth of paint and paintbrushes. I am also purchasing blank cards. What's the cost of the blank cards? $3.50, okay? Does it tell me how many boxes of those I am selling? No, it just says per box. So usually we say per box. I have that. Okay. Now, this value, if I buy one box, that means I'm out $39.50. If I buy two boxes, I'm out $43, and so on and so on. That means the number of boxes is my value of X. Make sense? What they're asking us to do is figure out if I'm going to sell them for $5 a piece, these two values have to be the same to know where I break even. Breaking even means where do they equal? Do you also agree that both of those are linear equations? So that means that somewhere along the line, 5x has a slope of 5, right? Intercept at 0. The other one has an intercept of 36 and a slope of 3.5 or 7/2. So we're trying to figure out, where do those two meet? Where do I start making money? How many boxes do I have to make in order to make it have it work itself out? That's what it stands for. Okay, that's what this looks like. So when you do the math on this, I think you wind up with I think we did this yesterday. Was it 24?
Yeah.
So you have to make 24 boxes in order to just break even on your initial investment. For how much? 120. Yeah. So it's a lot. That's not even taking into account your time, is it? Yeah.
Just all for.
But then you have, I mean, you're right. If you sell it for more,
But then you run out.
well, it's not so much running out. I mean, if you sell it for more, then it's supply and demand. You have to learn where's the butter zone, if you will, of the pricing. You know, if you don't want to price it so high that no one's going to buy it, and you want to price it so low that you're never going to make any money. Okay, and that's kind of where this stuff goes into play. Does that make sense on that one? Once you break it down into understanding what it means for sales stuff, I think it's a lot easier. And I know most of you guys haven't ever dealt with any econ stuff yet, have you? There's a couple other problems that we get into later on, probably in the next week where we do a little bit more of the sales figure things. And it'll make a little bit more sense about where things break even and stuff. It comes in, it's kind of a very common, it's actually linear programming that we get into. Okay? Now the other word problem dealt with, when was the last time, or have any of you even used a VCR?
Yeah.
All right.
Oh, yeah.
Basic take a microphone.
Nice. There was a thing on VCRs, your parents could probably attest to this. Back in my day, there were different types of VCRs. There were VCRs that had ways of programming to record. You actually had to record TV, live TV on a VCR. And maybe, just maybe, your VCR was fancy enough where it could record one channel and you could watch a different channel at the same time.
That's crazy.
Well, back in the early 90s, it was huge, okay? VCRs back then, I ran into an ad. I think a VCR that could do something like that in, I would say 91, 92, was probably around $300, $350 for a VCR like that. Yeah, their money.
Yeah.
So now, if you think about, who get the Google machine out and find out, you guys know,
Yeah, you got the irresponsible file.
the shoe fits.
Wow.
And get the Google machine and see how much is $350 was worth from 1991. In 1991 in today's prices. 91. It's probably around $500. So $350 back in 91 is $645 nowadays. So it's crazy when you start to really think about how much things really cost back in my day, how it worked itself through. Now, anyway, back with this, when you have these things called VCRs, you also have these things called coaxial cables.